This time we're going to talk about an easy LeetCode question called merge sorted array. In this question, you are given two non-decreasingly sorted arrays, nums1 and nums2. And you are asked to merge them into a single array while maintaining the non-decreasing property. In terms of the constraints, both arrays have less than 200 elements, and each element has value between negative 10 to the 9th and positive 10 to the 9th. Let's now try to visualize the two sorted arrays. Imagine how we, human, will solve this problem. Assuming that the first array has values 1, 2, and 3. And the second array has values 2, 5, and 6. And our task is to merge them into an array that is still sorted. We will have a big sorted array that is default to empty. Naively, I would like to focus on both the first elements in each array. And when comparing these two values, I would like to move 1 from the first array to the merge array. Just because it is the smallest value among two arrays, I should put it as the first element in the merge array. After that, I'm going to move on to the second index in the first array. Now, when comparing two values, 2 here, they're the same. I don't really care which one I use. But let's just use the first element in the second array this time. I'm going to move this 2 to the merge array. And again, I'll move my pointer to the second element in the second array. Now we would repeat the same procedure in comparing value 2 and 5. Since 2 is still smaller, I'll move it to the merge array, and so on, right? Now it's 3 and 5. I'll still put 3 in the merge array. And then that's the end of the first array. At the end, I'll move 5 and 6 from the second array to the merge array. And that finishes the procedure. There's one more thing I want to cover here, because this question actually asks us to not return a new array, but rather to put merge results in the given nums1 array. We need to do some special pre-processing of the array. What we're given is actually 1, 2, 3, and zeros for the remaining spaces, and 2, 5, 6. In order to make spaces for later merge procedure, what we can do is actually move the elements in the first array to the end. What will happen is we actually have this before the procedure starts. By doing this pre-processing, we can ensure that we have enough space during the merge procedure and no value will be overridden accidentally. However, we need to make sure that the move procedure is in the right order. We need to first move the last element we care to the end of the array, and then the second to the last one, and so on. If we change the order, then some unexpected results might happen, and let me demonstrate what that means. If somehow the given array is 1, 2, 3, 4, 0, 0, if we start moving the last element to the end, then everything will just work correctly. However, if you flip the order, let's say we start from 1 and put it here, the value 3 will be overwritten ahead of time. So when it's time for 3 to move to its desired position, the result has been gone. So the pre-processing order matters. We should move the last element that we care to the end of the array first and do it backward. So this is the last thing you need to keep in mind. This is basically the procedure we need to follow during the code implementation. And now let's jump right into it. As we discussed earlier, we need to do some pre-processing on a nums1 array so that we will have enough spaces for a later merging procedure. What we'll do is I'll first enumerate all the elements in the nums1 array, but in the reverse order. And for each element, I'll move them n step forward. After the pre-processing, let's move on to the merging part. I'll first define a few pointers. There's the pointer pointing to the merge array at index 0. There's a pointer pointing to the elements we care about in nums1 array, and it's going to be n. Lastly, there's the pointer pointing to the nums2 array at 0. Next, I'll keep comparing the elements that f index and s index pointing to, and move the smaller one to the merge index. Specifically, I will do smaller than n plus n. S index smaller than n. I'll check if nums1 f index smaller than 2 s index. If it happens, we'll do something. Otherwise, we'll do something else. If this happens, I will do nums1 m index equals to nums1 f index and increment those pointers by 1. Similar for the other case. I'll just move the s index in the nums2 array to the merge position. So I'll need to adjust the pointer here. This while loop will only end if either of the array is completed. And in order to make sure all elements are in their desired position, I'll need to do an exhaustive move here. I'll first check if the f index is at the end of the array. If it does not, then I'll move all the elements toward the merge position. And it's similar for the other case. If index more than n, I will just paste it here. And this should conclude the implementation. And let's see if it works. Okay, so since all the cases passed, let's do a submission here. It seems that its performance is pretty okay. And that's the end of this video. Thank you for watching.